Good morning. Today is Tuesday, the 14th of January of 2020. Hey, Bradley, if you're watching, this one's for you. Okay. Oh, no, that's you. Okay, well, we're good. Well, what's our title? It is the normal distributions. What's our learning goal? Greenleaf.
I can use statistics to help understand the world around me.
Excellent, Miranda. Why? Why do you care, Miranda?
More complex statistical methods are used in engineering, finance, and medicine. I want to understand how statistics can be used in real life.
Yes. If you flip a coin, you've got about a 50% probability of hitting heads, right? If you roll a die, it's a 1 in 6 type of thing. Well, what's the probability that in the U.S., that if we look at the entire population of adults, let's go with adult male. What's the probability that an adult male is 5'6"? Pretty likely. So I think average in the U.S. is probably about 5'9" right now. And 5'9", 5'10", somewhere in that. We can actually figure this kind of stuff out using statistics. And it's based off of what's called a normal curve. This doesn't work for everything, but it works for certain things in life. This is what the normal curve looks like. It's also called a bell curve. Why is it called a bell curve? Because it looks like a bell. And kind of like a bell. All right, that's fine. You're going to see the next bell curve. Okay. Here's the deal. Height is normally distributed, meaning it spreads out like this. You've got some people that are super short, but not very many of them. Actually, even you guys would be right in here. Then you've got a whole bunch of people that are kind of average. A lot that are a little bit above and a little bit below. And then over here, just a little bit of people that are really, really tall. It's a normal distribution. Most of the people are right in here. A few people at the edges. Intelligence is also normally distributed. Meaning, you've got a few people down here that just don't have it going on. And then over here, we have the Einsteins.
That's Luke. Someone on that scale over there.
Luke. Oh, you guys, this is really, really rare over here.
I have the IQ of a rock.
A rock? What kind of rock?
I'm a Geo.
Are all rocks the same?
More like
No, some rocks are sharper than others.
Dude, I have that IQ of a chicken from Moana.
Right there. I know you're smarter than the chicken. You're making a chicken joke. You're smarter than a chicken. Okay. Now, this is not everything in life. This is a very few things that are normally distributed, where you've got a few at either end. Grades on tests sometimes do this. That most people are just kind of getting an okay grade. Some are bombing a test. Some are doing really well. But it's not for everything. But if it is a normal distribution, whatever we're talking about, if it is a normal distribution, we can use that to determine what percentage of people are within a specific range. So I'm going to give you a really cool piece of paper. And when I say that, I really just mean I'm going to give you a piece of paper. It has some curves on it. You will need this information for the test on Thursday, but both of these curves are built into the test. So if you don't have your paper, you can just use the stuff that's built into the test. Hi.
No. You did? Why?
I don't know. Why do you and your dad buy lawnmowers?
He has stuff better now.
Yeah, just
In your birthdays?
6'8". I don't know, man.
Try to just like an RV or something.
That's what I'm gonna do. Every time I do it,
That
load
sounds
up.
legit.
See, I guess
Yeah,
so.
And
then it swerves on the side.
he's a foot and a half taller than me, and it's not fair.
All right. So in our notes, actually, before we take notes, I want to try to explain something to you. You can look at that paper, and then we'll get into the notes. Let me go back to this. Yeah, I'll go back to this one again. Actually, imagine that this is actually an aerial view of some kind of a land mass. It's an island. You with me? This is the aerial view of an island. And the people are normally distributed, meaning they're not all glumped together on one corner of the island. They're all just spread out. And there are 100 people on my island. And now it's my island. How many people live over here? 50. How many people live over here?
50.
Cool? So, and if this is height, half of the people in the world are less than 5'8", and half are taller than 5'8". It's if that's the median, or the mean. Excuse me. I'm making the numbers up a little bit. Now, let's divide my island up even more, and you can follow this on your piece of paper. %34% of people are there, and 34 are right there. Do you see it on your paper?
Yes.
Then I break it up here and here. Was this 12.5? 13.5. I do not expect you to memorize these. You will always have that paper. And then I come out here, and I think I'm at 2.4. Now, please get out a calculator and add up all those numbers for me. These are the people. I know it's hard to have a 0.4 of a person, but it's possible. I mean, we got JJ.
They're like,
It's fun to have people in class that I can, that aren't going to get all, you know what I'm talking about. Yeah, you're fun. You got. If you add all those numbers up, what does it become?
The other 99.8.
99.8.
What other point you got? They died.
So 99.8, which means this would be a 0.1.
Oh, okay. Nice.
Ish. So the question is, how did this actually become these lines? I think you're understanding, yeah, I'm drawing these lines and I'm telling you how many people live in each area. But how do these lines actually come into existence? Well, I'm going to show you how they come into existence on this problem. This is going in your notes. I have a mean. Why is my heater on? Okay, we'll leave off.
It's really hot.
It feels warm, right? Mean of 78 and a standard deviation or a sigma. Yep, yes. I'm going to write the words at least for the notes. Of 3. I'm going to turn it off. It's only 70 in here.
That's like 70? Turn it like 68.
Well, I mean, everyone's very.
No, you know, it's on though. They say I'm hot.
I feel good.
I'm not so sure.
Oh yeah, trying to get up to 70. Yeah, let's see what goes on.
Maybe it's loaded.
All right. So in your notes, taking up the full width of the page, but leaving a little bit of space at least under it, we're gonna draw a normal curve. It's not gonna be perfect, that's okay.
Oh, wait.
Get this into your notes. It's not perfect, but that's okay. You like that? It's supposed to take up half the sheet, the width of your page.
Dang it. This is not even. That's
Mr. Barre, is that size okay, or does it have to
It's
be
okay.
bigger?
One, two. Draw a line through the middle. What do you think determines, raising a hand, determines that line? The mean. That's the mean right here. This is the 78. So this middle line is created by the mean, and it's at 78. The line above and below it, if you look at this, what symbol is that?
Deviation.
It's a standard deviation, which is a sigma. I'm going to go up 1 deviation, 1 sigma, and I'm going to go down 1 sigma. So I'm going to go up 3 and down 3. What's up 3 from this?
81.
And what's down 3 from this?
75.
I just cut it into those two regions. How many people live right here?
3.
Nope. How many, what percent?
34%.
How many people live right here? How many people live right here?
13.5.
68%.
68%. Excellent, Chris. We're now going to go out 1 more sigma, 1 more deviation. I went out 1, now I'm going out to 2. So 81 plus 3, 75 minus 3.
72.
How many people live right here?
13.1%.
How many people live here?
34%.
Here?
34%.
Here?
13.5.
Let's go out 1 more sigma.
87.
61 or 69.
69. And what is this, 2.4? Now I can find what percent of people live in any of these little regions. What percent of people live between 81 and 84?
13.5.
No,
Wait.
15.9.
Between 81 and 84? 13.5.
Oh.
What percent of people live between 75 and 81?
68.
What percent of people live between 75 and 84?
70.
81.5.
81 point.
Yo, quick math.
No, 82.5.
81.5.
It's
81.5. 81.5. Now, there's something weird that you're going to notice on this paper. Depending on which one you use, the numbers are going to be slightly different. Using the top paper, the top graph, what percent of the population lives between 72 and 84?
99.7.
95.
95, correct?
Yeah.
Oh, yeah.
Okay. using the bottom graph, what percent lives between 72 and 84? Get out those calculators and add up the percentages.
95. Yeah.
Is it still up? Okay, 95. Now, what percent lives between 69 and 87 according to the top graph?
99.7.
99.7.
7.
According to the top graph. Look at the top graph.
99.7.
Do you have your paper, Chris? Look at the top graph. 99.7. According to the bottom graph, what percent lived there? 99.8. When you do IXL tonight, it's weird, but they're going to expect different numbers for different things. If it's symmetrical, use the top graph. Right? If the area I'm looking at is symmetrical on both sides, use the top graph. If it's asymmetrical, meaning it's not symmetrical, then you're going to use the bottom graph. So if I said, tell me top or bottom, I want this area, top or bottom.
Bottom.
60.
Top.
Oh.
Top graph, right? I want this area, what graph? Top graph. I want this area, what graph? Top. I want this area.
Bottom.
I want this area.
Top.
I want this area.
Top.
This area?
Bottom.
This area.
Top.
This area.
Bottom.
This area.
Top.
And I think IXL is going to want you to do it that way. It's really only important when you start getting way out here to the edges. All right. You can do this. Get out a whiteboard and a marker. High five. Come on. Come on.
Oh, we're gonna sweet.
I think I accidentally split it yesterday, and I was like, oh wait, it's yours. Like, no, you gave it back. I did. Hey, I put you in here.
That's cool.
Yes. Yes. I always have no.
You do not need to write anything on your whiteboard. Yeah.
Yes. I did this too. Wait, are we doing homework?
No, we're still working together.
Oh.
My mean is 55, and my standard deviation is 16. Cool? You're going to be putting one number on your board. What number is going to go right here on your whiteboard? Good. I'm kind of graphing out this thing. What number would go right in the middle of this curve? Good. Good. I'm just seeing if you're catching what we just did. Good, you've got it. Coming back over here. Good. Ooh, be good. You're burning my eyes with that marker. 55. I want to go up 1 sigma. What number would go right there? Perfect. You're catching it.
Get out of here, kid.
Good, you got it. Good. No, check your math. No, check your addition. Good.
Wait, what?
Oh.
Good. No.
Wait, you're going up 1 sigma.
1 sigma, 1 standard deviation.
Oh.
You're going up 1 standard deviation. Good. 71. How did I get that, Aiden?
Because the sigma is
Which is 16, so I did 55 plus 16. Now, I want you to go down 1 sigma.
Oh wait.
Maddie's like, oh, Mr. Barr, make me do subtraction now. Dude, my life is so lame. Is that a 9 at the end of that? Yeah. Good, good. Good, good. Okay. Take it down another sigma. Yep. Good, 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 good. Oh.
Oh, did I do math wrong?
Yes.
I did see the math wrong.
Subtraction.
6.
You did your math wrong too. It should be 23. That says 23?
Yeah, I did the 3 wrong.
Oh,
Because it looked like a 7, so I tried to redo it really fast, but then it didn't
But I did it wrong.
What?
Okay.
I did do right, but I did wrong.
Take me up to 2 sigma.
What?
Wait, what?
Oh.
2 sigma.
Oh,
you
you
guys-
sigmas?
Oh, 2 sigmas.
I'm just jumping around. Good, good. Good, good, good.
That's a
Good there.
bad
87.
Good.
No.
Nope. 87.
What do you say? Take 1.
Well, this is 1 sigma. This is 2 sigma. 17 plus 16, or 71 plus 16. Is that 80, 87?
Oh, I thought 7
I know.
was yeah.
So this is 1 sigma. This is 2 sigma. Take me up to 3 sigma. 3 sigma. Good, good. Is that a 3?
Yeah.
Got it?
I'm sorry.
Oh,
I'm
oops.
writing.
Oh, yeah. I got 99.
I've got it as 103.
Me too.
Oh, were you coming down here?
Yeah.
Okay, and what's this?
7. That is.
There it is. Now that we've divided up all the percentages, we can actually answer a question. So the question is this. What is the probability that a person lives between 23 and 87? What are the data about? 23, ready? What's the probability that you live in that area right there? Give it to me on your whiteboard.
Can't do math.
You just have to add numbers together.
I know.
Actually, it's on the top graph, isn't it? It's symmetrical.
Will it always be on the top graph?
No. So, I'm going to mix it up in a second.
So
Percent. IXL is going to want you to write it like this.
why?
Just don't trip
Oh,
out.
because of the.
Because 0.95 is 95%.
Yeah.
Because a percent is per 100. So,
Do we write percent after?
IXL is not going to care. This was symmetrical, so we could use the top graph. I'm going to make it asymmetrical.
Whoa.
What percent of the population is between 39 and 87?
I got it. It's underneath this right here.
That's incorrect.
What? Oh, I did it.
82 point.
That's incorrect.
How did I get it? Oh.
Yes, 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 yes.
Math wrong.
Yes.
Me.
Yes, 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 yes. So what you're doing is you're adding up 34, 34, and 13.5.
Oh.
Because that's what I'm looking at on my graph. Basically, I take my numbers and I overlay it onto this, and then I can answer my questions.
Yeah, I just got.
It's not.
Is it? Yes.
Let's do. Let's go with number 11.
Wait, what's number 11?
Let's do number 12.
Oh.
Number 12.
I like that.
Actually, you know, just.
Do we have to have the deviation standard?
So what you need to make this work, you have to have the mean and the deviation, standard deviation. So what is my mean here?
80.
80. And what's my standard deviation?
18.
18. So I can do it like this. 80. Now what comes up next?
98.
And next? 116?
Yeah.
Yes.
And next?
134.
There, yeah.
Okay, take me down.
70, no,
62.
Take me down.
54.
44.
Take me down.
26.
26.
Good. And now, once I've done that, I can start answering questions. What percent is between 26 and 44? So what chunk is right here? What's this chunk?
2.4.
2.4. What percent is between 98 and 134?
4.8.
Nope.
What?
Wait, what? Between 90
What's between 98 and 134?
15.9
Right? Because it's 34. What was it? 13.5.
and 2.4.
So I'd add those two numbers together. Jackson.
How do you know how far to expand it out?
I expand it out far. So I usually go out 3 sigma when I'm doing mine, but you've got to go far enough out that you can catch the numbers they want you to catch.
Oh,
So you got to read the problem. So maybe it only says, hey, go down. You've got to really look at the numbers. So this said 26 to 44. I come over here, 26 to 44. I know that's 2.4% right there.
so if it just said like 62 and 90.
Yeah, if it said, hey, what percent between 62 and 98? I usually just take it out 3 sigma though. Okay, I'm gonna let's set you guys free onto some IXLs, and then I'll start working with people individually if you need help.
And we also use algebra.
Algebra 2?
And yes, it is algebra 2.
We're doing some like